Okay, let's start here. So I'm going to have a normal to my surface. And I'm also going to have another normal to my surface. And then I'm going to try to draw an incident light. So let's do that. And let's say this comes out here. Let's say it goes in here. So this angle is 90. This angle is 90, even though it may or may not look 90. But imagine that these are all 90 degrees. My incident angle, theta I, is this one. My refracted angle, theta I prime, is that one. This is my theta 2 prime, and that is my theta 2. I need to do another line. I'll do it with this one to make it clear. Let me erase this. So this is my theta 2. Let me color this out so it's clear. So this is my theta 2. So that means that and that. This should be my theta 2. And the black one is my theta 2 prime. This whole. I also have another thing I want you guys to worry about. Yay. Is this imagine this is the original incident angle. Then what is the deviation? And if I draw this one backwards, oh, this is gonna look ugly, but that's my deviation. It's not that big. Like if you look at it in the inside, that's this angle.
Yeah.
And then I want you to redefine these angles. Pick a color that will be different.
Green.
Green. This angle, I'm going to color it in, and that angle. I want you to call them delta 1 and delta 2. Okay, so delta is the deviation. A is the apex. Theta I is the incident. Oh, so theta, I call it theta 1. Just for easy figuring out what things are. So I'm going to use this as my base. And I'm going to tell you, to make life easier, that the light passing through the prism passes through symmetrically. What does that mean? That means theta I or theta 1 is the same as the theta 2 prime. So angle of incidence equals angle of emergence. So in these cases, there is a refracted angle and then there is an emergent angle. Theta 1 prime is the angle of refraction, and theta 2 prime is the angle of emergence. Now, can I write from the figure these things from the picture? Delta 1 equal delta 2, which are the angles of deviations. And because of symmetry, can I also write theta 1 prime equals theta 2? And this is from symmetry. Can I also write 1, 2? Can I also write, oh, that will be not enough. Some of the internal angles delta 1 plus delta 2 equals delta. So sum of internal angles in a triangle equal the external angle from geometry. So these two, the ones in the green, are equal to the delta that's outside. That's geometry. Nothing fancy here. And since delta 1 and delta 2 are the same, may I write this as 2 delta 1 equals delta? Or delta 1 equals delta over 2? And call this equation A. I also know Snell's law. So can I call it n prism? Sine of theta 2 equals n in air, sine of theta 2 prime. Or I could write n prism divided by n air equals sine of theta 2 prime divided by sine of theta 2. Problem, I don't know this and I don't know that. And I don't want to keep calculating theta 1 and theta 2 for every single light that's incident. So I have to come up with an equation that I just can know and not worry about each of the theta 1s and theta 2s. So here's the trick. I know if you stare at this triangle, can you write the sum of the angles, this one and that one? So if I just take this triangle here, I'm going to try to redraw this triangle in the green. So if I redraw just that part of the triangle and call this was my A, I will call this angle B and I'll call this angle C. Is it true that A plus B plus C equal 180 degrees? Yes? Okay, now if I look at my angle B and I go like this, and there was a 90 degrees here, and this was my angle theta 1 prime, and this is 90 degrees. So on this line, can I write B plus theta 1 prime plus 90 degrees is 180? And I'm looking at this line. So then may I write angle B as 90 minus theta 1 prime? Good? Okay, now I'm going to go to the other side. So I have this angle here. And there was a line, which was normal. And this angle was called theta 2, and that's 90 degrees. Following the same logic, can I do C hat plus theta 2 plus 90 degrees equal 180? And then may I write C as 90 minus theta 2? And may I plug all of these in here to get A hat plus 90 minus theta 1 prime plus 90 minus theta 2, that's a prime, equal 180. And I can simplify it to give me A hat minus theta 1 prime minus theta 2 equal 0. Yeah, there's 90s on both sides. I started by the assumption of symmetry, and I said, symmetry tells me theta 1 prime equals theta 2. So may I rewrite this as A prime minus 2 theta 2 equal 0? or theta 2 equals A over 2. And that's what we're going to fill everything else in. Okay, once I have this done, I can plug that in here, right? So half my problem is solved. Now let's look at the other half. Okay, I'm going to come back here. I'm going to come back in here. What do I see? Delta 2, if I look at the green signal, delta 2 equal, okay, I'll do it this way. Theta 2 prime is the same as theta 2 plus delta 2. You can see it? You can see it. So I'm going to come back down here. Got it? Everybody ready? Sure. I'm just going to rewrite this again. Theta 2 prime equals theta 2 plus delta 2. Yeah? What was theta 2? And what was delta 2? Going back here, we solved for it in equation A. What was that? Delta over 2, right? So theta 2 prime will be what? Yeah. And what were we looking for in the star bubble? Both of those angles? Yay. This is called the prism equation. And what is so beautiful about it? Guess how many variables you actually need to know? 2. Which ones? A and delta. And what was delta? Deviation. Okay. And yes, it is ND minus 1. You were looking for a value. I was like, I don't know. Right, just the name. Okay. So instead of now worrying about each of the thetas, which can change if you change the angle, you now have this beautiful equation that only worries about your apex angle and one value. Woohoo!